Any assembly language instruction that is not a mnemonic for a hardware executable opcode is known as a pseudo instruction. A pseudo instruction is a command to the assembler, not an instruction for execution in the program being assembled. Another name for a pseudo instruction is a directive. You can argue about the shadings of meanings between these two terms, but I consider them just to be the same. It makes life easier. The previous lesson demonstrated some directives. It described the equate instruction that can be used to define constants, and several instructions you can use to declare locations in memory to hold data. But there are a number of pseudo instructions that do other things. There are directives that will group the object output from the assembler into segments. This is a very different thing from the hardware segments discussed earlier. These segments are designed to hold different parts of a program, which may or may not happen to be in different addressing segments described earlier. There are also pseudo instructions that will conditionally prevent or allow blocks of code to be assembled as part of the program. And of course, there are instructions that will include other files as part of the code to be assembled. The inclusion is done by a preprocessor. Assembly language code is preprocessed just like C. In fact, that's where the designers of the C language got the idea. The code you write is normally in 3 segments. You specify the name of each segment using the segment directive like this. The order of the segments doesn't matter. The linker straightens that out. The data segment is the one that you use to hold all initialized data. The second is the BSS segment, which is where you put all uninitialized data. The third segment is the text segment, which is where the executable code goes. There is a lot more to all this, but most of it doesn't apply until you're a bit more advanced in assembly language. Some things you need to know about, though. For example, you might want to use the word section instead of segment. Either one will work. They're both the same. Some object formats don't use segments, so they just ignore the information and throw it away. For other object formats, you can even make up your own segment names. You'll find more information about using these 3 in the upcoming lesson about source code layout. When you want to refer to a symbol that's in another module, you use the extern directive. That way the assembler knows to pass the symbol information on to the linker and let it take on the job of locating things and hooking them up. You can put several symbols on one extern directive, and you can use as many extern directives as you need. The flip side of extern is global. This is a directive to tell the linker where the symbol is located in the assembly language program so any other modules that are looking for it can find it. And there is yet another one, a very special one. This example of the common declaration does the same thing that RESB does. It declares a block of 4 uninitialized bytes of data. You do this in the BSS segment, and it's the same as declaring it as a global name. Well, almost the same. The difference is that if this same name is declared in more than one module this same way, the linker throws them all away but one. Effectively, it merges them all into one. It is a way of creating commonly shared data blocks. And as you know, there are a number of Intel and Intel-compatible CPUs, and they all have different sets of instructions. If you want to specify which CPU you want to write for, you can use the CPU command with a keyword that names the instruction set that you're going to use. That way, all the instructions for that machine are available to you, and if you try to use an instruction that doesn't exist in your target machine, you'll get an error.